name is Caleb, and this is Lab 3, Circuits. The purpose of this lab is to understand how current and voltage travel through circuits with resistors and capacitors, and measure the electric current and potential difference. The findings and results include the current through the R47 resistor, which was 21.5 ohms, and the R100 resistor, which was 20.9 ohms, and the ammeter, which was 0 ohms. The time of charging and discharging of the capacitor were approximately equal. Some of the fundamental principles include Kirchhoff's voltage law or the loop rule, Kirchhoff's current law or the mode rule, and Ohm's law. The conservation of energy we could see is that the R total, which is just R1 and R2, which is the ohms of the two different resistors, 147 came out to 147, and the current, which is calculated by voltage over resistance, was 0.02 amps. The current in the first ammeter was 15.3 mA, and the current in the second ammeter was 10.9 mA. The change in voltage for the batteries was 1.59 volts and 1.57 volts. The 47 ohm resistor had a change in voltage of negative 0.919 volts, and the 100 ohm resistor had a negative 1.986 volts. The potential difference was negative 3.1 volts, which means there was roughly zero change of voltage throughout the entire circuit. The 100 ohm resistor current was calculated with the voltmeter and was 20.9 mA, and the 47 ohm resistor current was 21.5 mA. Part 2, which was when light bulbs were added to the battery and capacitor, it was observed that the bulbs gained brightness and then went dark after a while, with the current reducing to zero. When the battery was disconnected, the bulb got brighter again and then went dark. The results included the charge time, which for 20 ohms was 1 minute and 1 second, and for 10 ohms was 15.05 seconds, and for discharging was 20 ohms was 54.18 seconds, and for 10 ohms was 14.38 seconds. The observations we had were that the time doubles as the resistance doubles, and the charge and the discharge times are very similar, and the bulbs would dim as time passed on. If question of if you charged a capacitor with no resistor in the circuit, how quickly would our ideal model predict the capacitor to reach full charge? Would this prediction happen in real life? And to answer that, a capacitor would charge instantly in the ideal model. However, because the wires have resistance, which would cause the capacitor to take a short time longer than what it usually would be. Some possible errors include an inaccurate measure of ammeter and voltmeter readings and human error with the stopwatch timer.